Welcome back, everyone, for another deep dive. This time we're going to be tackling something pretty massive.
Literally.
Yeah, literally massive. Black holes. Specifically,
A black hole.
right, a brand new discovery that has astronomers scratching their heads a bit.
Yeah, it's a fascinating one.
We'll be looking at this new paper, all about observations from the James Webb Space Telescope. They found a dormant black hole dating back to the very early universe.
Really early. Like we're talking just 800 million years after the Big Bang.
Wow. And this thing is a real whopper.
Oh, yeah. It clocks in at 400 million times the mass of our sun. It's a beast.
Jeez. For that early in the universe's history, I mean, that's...
It really is an outlier. It raises a lot of questions about how black holes form and grow in the early universe.
Yeah, and the paper keeps using the word dormant.
Right.
What exactly does that mean? 'Cause I always thought black holes were like...
Voracious eaters.
Yeah,
Yeah.
constantly pulling in matter.
That's the common perception. But this one's not actively feeding. It's accreting at a very low rate. Yeah, pulling in matter. But much slower than we'd expect for a black hole of this size. It's about 100 times below its theoretical limit.
So it's like it ate a huge meal and is now just napping.
Exactly. Taking a cosmic nap to digest, you could say.
That seems strange. Why is this discovery causing such a stir?
It challenges our current models of black hole growth.
Really? How so?
Well, its sheer size at such an early stage in the universe.
Makes it kind of hard to explain.
Yeah, it doesn't fit neatly into the narrative we've built around black holes.
So how are scientists trying to explain this?
There are a couple of main theories. One is that some black holes are just born big.
You mean they form with a massive size right from the start?
Exactly. They skip the slow, gradual growth process we typically see.
So like a cosmic shortcut to being supermassive.
That's one possibility.
What's the other theory?
The other possibility is that black holes go through periods of incredibly rapid growth, like growth spurts.
Okay, interesting, like a teenager suddenly shooting up.
Sort of. Followed by extended periods of dormancy. So this black hole might have gorged itself early on and is now just chilling out.
Both of those possibilities are pretty mind-blowing.
I know, right? And they have pretty huge implications for our understanding of black hole evolution.
So what evidence are researchers looking at to support these theories?
Well, they've been running computer simulations.
To try and recreate this?
Yeah, to model how this black hole could have gotten so big so fast.
Makes sense.
And
And what if they found?
the simulations suggest that black holes can sometimes exceed the Eddington limit.
Which is?
Basically the speed limit for how fast a black hole can pull in matter.
Oh, okay.
So it's like this black hole went into overdrive, gobbled up a ton of matter, and now it's taking a break.
Wow, so it really pushed the pedal to the metal.
You could say that.
Is there any indication of how it was able to break that speed limit?
The simulations offer a couple of possibilities. One is that it was surrounded by a really dense disk of gas early on.
Like a buffet.
Yeah. And that gas shielded it, allowing it to pull in matter more rapidly. Another possibility is that it was spinning really fast, which could also have increased its accretion rate.
Fascinating. So, if this black hole could grow so quickly, could other black holes in the early universe have done the same?
That's the million-dollar question. And it's very possible.
So there could be way more of these dormant giants out there just lurking.
It's a real possibility. Since they're so hard to detect, this discovery could just be the tip of the iceberg.
Okay, so we've established that this black hole is super unusual. It's huge, it's dormant, and it challenges everything we thought we knew about black hole formation. But why does this all matter?
Well, on a fundamental level, it changes our understanding of how black holes work.
Okay, I get that. But like, what are the broader implications?
It could have a big impact on our understanding of how galaxies evolve.
You mentioned this black hole makes up a huge portion of its galaxy's mass, right?
Yeah, like a whopping 40%. That's way more than what we typically see in the modern universe.
So black holes might have played a much bigger role in galaxy evolution than we thought.
Exactly. Instead of just being one component, they might have been the driving force, shaping the structure and growth of their host galaxies.
So in the early universe, these black holes were calling the shots.
It seems that way.
It's pretty wild to think about. This one discovery has really opened up a whole new avenue of research.
Absolutely. And it just goes to show how much we still don't know about the universe.
This deep dive has been a wild ride through the world of black holes, but we've only just scratched the surface.
Oh, there's so much more to explore.
So we'll be back to delve deeper into the implications of this amazing discovery after a quick break. We'll examine how this finding could change our understanding of black hole detection and examine the potential links to dark matter and dark energy. Stay with us. So, we're back and ready to jump back into our black hole deep dive. Before the break, we were talking about this massive dormant black hole and what it could mean for our understanding of the universe. One thing that stuck with me is how this discovery might change how we look for these things.
Yeah, it definitely throws a wrench in our traditional methods.
Right, because if dormant black holes are more common than we thought.
We need new ways to find them.
Exactly. So how do we find these hidden giants if they're not actively feeding and blasting out radiation?
Well, astronomers are exploring some pretty cool approaches.
Right.
One method is to look for their gravitational effects.
Even if they're dormant.
Yep. Even when they're not eating, their gravity is still warping space-time around them.
So we could actually see the distortion.
In a way, we can observe how their gravity bends light from objects behind them. It's called gravitational lensing.
Ah, so we can use that lensing effect to spot them.
Exactly. It's like using the black hole's own gravity to reveal its presence. Pretty neat, huh?
That's amazing. Are there any other techniques in the works?
Yeah, another approach is to look for the remnants of their past activity.
So even though they're quiet now, they might have left some traces behind.
Precisely. We can search for signs in the gas and dust surrounding them, left over from when they were actively gobbling up matter.
It's like cosmic archaeology, digging for clues about their past feasts.
Exactly. And luckily, we have some powerful new tools for this kind of cosmic detective work.
Like the James Webb Telescope.
Exactly. The JWST is a game changer for this kind of research. Its infrared capabilities let us see much fainter signals than ever before.
That's incredible. Now, as we learn more about these dormant black holes, we're also starting to think about how they might connect to some of the biggest mysteries in cosmology. I'm talking about dark matter and dark energy.
Oh yeah, those are the big ones.
For sure. Let's start with dark matter. Can you give us a quick reminder of what it is and why it's such a puzzle?
Sure. Dark matter is this mysterious stuff that doesn't interact with light. We can't see it directly.
So it's invisible.
Exactly. But we know it's out there because of its gravitational effects on the stuff we can see, like galaxies and stars.
Right, it's like the cosmic glue holding everything together, but we have no idea what it actually is.
That's the mystery. And that's where dormant black holes might come in.
Really? How so?
Well, some scientists have proposed that dormant black holes, especially the ones formed in the early universe, could make up at least some of this missing dark matter.
So these hidden black holes could be masquerading as dark matter.
It's a possibility. Remember, we could be vastly underestimating their numbers because they're so hard to find.
That's a fascinating idea. What about dark energy? How could dormant black holes be related to that?
That connection is a bit more speculative, but there's a theory called cosmological coupling that suggests a link between black hole growth and the expansion of the universe.
Cosmological coupling. I've never heard of that.
It's a pretty wild idea.
Yeah.
It proposes that as the universe expands, black holes grow.
Okay.
And that growth actually contributes to the acceleration of the expansion.
So it's like a cosmic feedback loop. Black holes feeding the expansion of the universe.
Exactly. It's a pretty mind-bending concept.
It really is. What's the thinking behind how this connection works?
The details are still being debated, but one idea is that the vacuum energy inside black holes.
The energy of empty space?
Right. That energy might interact with the vacuum energy of the universe itself, somehow pushing the expansion further.
So black holes might be fueling the expansion with their own internal energy?
In a way, yeah. But it's important to note that this is a very new and controversial theory.
Sure. Still a lot to figure out.
Definitely. The evidence is mainly theoretical at this point. But some recent observations of black hole growth seem to line up with what cosmological coupling predicts.
Interesting. So a lot more research is needed, but it's definitely a promising avenue to explore.
Absolutely. It could change everything we know about how the universe works.
This has been an incredible deep dive so far. We've gone from the specifics of this one black hole to its potential implications for some of the biggest questions in cosmology.
It really shows how one discovery can shake up our understanding of the entire universe.
Exactly. And this is just one piece of a much larger puzzle.
A puzzle that we're only just beginning to understand.
This dormant black hole has definitely woken up a lot of new questions, and I bet our listeners are eager to hear more about where this research goes from here.
I'm sure they are. There's so much more to discover.
Okay, so for the last part of our deep dive, we'll shift gears a bit and focus on what this discovery means for the future of black hole research and for our understanding of the universe as a whole. Stay tuned. Okay, so we're back for the final part of our deep dive into the mysteries of dormant black holes. Before we went to break, we were getting deep into the weeds with dark matter and dark energy.
Yeah, those are some pretty big concepts.
To say the least, it sounds like there's still so much we don't know.
Oh, absolutely. We're just scratching the surface.
Let's circle back to that idea of dormant black holes being a potential source of dark matter. You mentioned that they could really mess with our understanding of how much dark matter is actually out there.
Right, because if we're missing a whole bunch of black holes in our calculations,
Our measurements of dark matter could be way off.
exactly, they could be lurking in the shadows, secretly contributing to the overall mass of the universe.
So how do we even begin to test that idea? Are there any ways to find these hidden black holes and see if they really are contributing to the dark matter puzzle?
Well, it's tricky, but there are a few things we can look for. One is those subtle gravitational lensing effects we talked about earlier.
Right, using the black hole's gravity to distort light from objects behind it.
Exactly. If we can find more instances of lensing that can't be explained by visible matter, that could be a sign that dormant black holes are playing a role.
Like finding a fingerprint at a crime scene.
Kind of. Another thing we can do is study the distribution of dark matter in galaxy clusters.
How would that help?
Well, if dormant black holes are a significant part of dark matter, we'd expect to see them clustered in similar ways to other dark matter.
So if the distribution patterns match up, that would lend some support to the idea.
Exactly. It's like trying to piece together a puzzle with missing pieces. We have to look for clues wherever we can find them.
Makes sense. Okay, now what about that connection to dark energy and cosmological coupling? That one really blew my mind.
Yeah, it's definitely one of the more radical ideas out there.
But also super exciting. Just to recap, this theory suggests that as the universe expands, black holes grow, and that growth somehow feeds back into the expansion, making it accelerate even faster.
Right. It's like they're pushing the universe apart from the inside out.
It's wild. What would the implications be if this theory actually turned out to be true?
Well, it would mean that black holes aren't just these passive objects sitting around in space.
Right, they'd be active players in the evolution of the universe.
Exactly. They would be shaping the cosmic landscape on a grand scale. And it could also tell us something about the nature of dark energy itself, which is one of the biggest mysteries in physics.
So we're potentially talking about a major paradigm shift in our understanding of cosmology.
Absolutely. It would be revolutionary.
But for now, it's still mostly theoretical, right?
Yeah, we need more observational evidence to support it. But the early signs are intriguing, and a lot of researchers are excited about the possibilities.
I can see why. It's mind-boggling to think about. This whole deep dive has been an amazing journey. We've gone from a single discovery of a massive dormant black hole to exploring its potential implications for some of the most fundamental questions about the universe.
And we've only scratched the surface. There's still so much to learn.
That's the beauty of science, isn't it? There's always more to discover. But before we wrap things up, I want to bring it back to the listener for a minute. Why should someone who's not a scientist or a black hole enthusiast care about any of this? What's the takeaway for the average person?
I think it's about the wonder of it all. Discovering a giant, dormant black hole from the early universe, theorizing about how it might connect to dark matter and dark energy, it expands our understanding of the cosmos and our place in it.
It's a reminder that we're part of something much bigger than ourselves.
Exactly. And who knows what other incredible discoveries are out there waiting to be made.
Well said. A huge thank you to you for joining me today and sharing your expertise. It's been a truly fascinating conversation.
My pleasure. It's always exciting to talk about these mind-blowing topics.
And to our listeners, thanks for tuning in. We hope you enjoyed this deep dive into the world of dormant black holes. Keep looking up at the stars and never stop questioning the universe around you. You never know what you might discover.